Welcome back, everybody. All right, so like I was telling everybody in the room, those of you watching along, I've got about 5 or 6 problems here that I want to talk through. They look oddly similar to the ones that might show up on the partner quiz tomorrow. And then the rest of the time, I will let them work on the assignment. Just so everybody in here and out there knows, let me get to our class here. On today's lesson on the section 5.5, I did post a video from last year, and it's just me going over homework questions. Okay, I don't know how good that is, but because I didn't rewatch it, but those are questions that they asked me from the homework assignment. So if you're stuck on one, you might want to jump on there and see if I explain it.
About how many questions is the partner quiz?
I think it's 8. 8. Yeah.
Okay. 6 questions.
Yeah.
Just missing 2.
That's right. All right, here we go. Don't know what I was going to say about that. Here's number 1. I have the integral of the square root of 3 plus 4x dx. Oh, I forgot to get this going too. On today's Algebra 1 state test, there were 3 box and whisker plot problems. I mean, box and whisker plots. Like nothing says Algebra 1 quite like a box and whisker plot. I mean, like, come on. Who's making these tests? I want to punch them in the face. Yes, that is recorded. I'll stand by that. All right, what do you think our u is going to be? 3 plus 4x. Right, 3 plus 4x. So u is 3 plus 4x. So that means du is 4 dx, right? Okay, now, do you notice how I don't see a 4 dx up in the original? Like here, I just see a dx. You know, we're going to replace this 3 plus 4x with u, but I don't see a 4 dx. That means I got to get this 1/4 over to the other side. So 1/4 du is equal to dx. So now I can put that in for dx. So this is going to turn into the integral of the square root of u times 1/4 dx. Nope, du. Thank you. Look. All right, so now I bring that 1/4 in front. I like to write it like this before I get going. Right? Now, let's take that square root and turn it into a power. So 1/4 u to the 1/2 power du. And now I can do the antiderivative pretty easily too, right? So this is 1/4 u to the, and I'm okay if you use fraction powers or decimal powers. It really doesn't matter that much to me. So 0.5, 1/2 is going to turn into 1.5 divided by 1.5 plus c. Now, I'd like you to reduce down the coefficients in front. That would be nice if we could do that. So 1/4 divided by 1.5. So as a decimal here, 0.16. As a fraction, that looks like it's 1/6. So that's going to turn into 1/6 u to the 1.5 plus c. Now, don't forget that in the end, you got to replace u back in with that 3 plus 4x. So 1/6 3 plus 4x to the 1.5 plus c. The only time where you do not have to do that is when you're actually evaluating a definite integral. A definite integral. You don't have to plug u back in as long as you change your a and your b values on your integral. We good there? That one's kind of an easier one, right? Somebody's excited. Is that outside or just downstairs? Okay. All right, let's take a look at this one. I'm going to make this one a definite. I'm going to go from 4 to 10 of dx over 7 plus 2x. Again, if you see something go haywire, let me know because, again, I just whipped these problems up, and I'm doing them for the first time right now with you guys. So if you're like, wait a second, what happened? Okay, now this one's a little weird. This one's a little weird because I've got it in a fraction, right? I got that dx over 7 plus 2x. Now let's manipulate it a little bit and say, okay, that means I've got 4 to 10 of 1 over 7 plus 2x dx, right? What do you think I'm going to make my u? Yeah, 7 plus 2x. Okay, so du is going to be, again, 7's going to go away, 2 dx. Which means if I divide by the 2, I get 1/2 du is equal to dx. Now, I keep getting it equal to dx. That's not always going to happen. Okay, there are cases where I need to leave stuff over onto the other side, and I have some examples of that as well. All right, now, so this is going to turn into, we'll leave that open right now, 1 over u times 1/2 du. I have to change my parameters, right? I have to change my a and b values because now that I've plugged in u, I need to change a and b going through u. So if I plug in 4, the bottom interval, if I plug in 4, what am I going to get? 7 plus 8 is 15. If I plug in 10, what am I going to get? 27. So I've got to change that into 15 and 27. And because this is a definite, it's going to allow me to not have to put x back in. Okay, so just manipulating it down a little bit. Again, this is from 15 to 27 of u to the negative 1. And I'll put this 1/2 in front. 1/2 u to the negative 1 du. All right, now at this point, I can find the antiderivative. 1/2 of, what's the antiderivative of u to the negative first? Ln of u. Absolute value. But when I go to plug it in, they're both positive, so that's not going to matter. 1/2 ln u. Now, do I need my plus c? No. I don't because this is a definite. So now I'm going to take 1/2 ln 27 minus 1/2 ln 15. 0.5 ln 27 minus 0.5 ln 15. Okay, 0.29. Well, we'll just say 0.29. 0.29. Again, I did not need to go back and plug in my 7 plus 2x because this was a definite, and I had already taken that into account by changing the a and the b values. If this was an indefinite, I'd have to go back and put the x in. Questions on that one? Let's keep it moving then. Next one I got here, just a plain old integral. This is number 3. Ln of x, all raised to the 4th power, over x dx. Okay, what do you think my u is going to be? What do you think? What's it look like it's inside something? Ln of x. So u is going to be ln of x. And if I differentiate ln of x, that's going to be du is equal to, what is the derivative of ln? Anybody remember? 1 over x. So 1 over x dx, which is actually kind of convenient because if I rewrite this, isn't this like saying this? Ln of x pulled out in front raised to the fourth power times 1 over x dx, right? Isn't that the same thing? If I take this whole chunk of ln of x to the fourth out front, that's ln of x to the fourth times 1 over x dx. And look at that, 1 over x dx, 1 over x dx. See, this one, I don't need to multiply anything over to the other side. I don't need to do any of that junk because that's all in my integral. So this is actually going to turn out to be the integral of u to the fourth. I don't need that parenthesis. U to the fourth du. It's kind of nice. Okay, so we say u to the fifth over 5 plus c, which turns into ln of x to the fifth over 5 plus c. Questions on that one? Okay. Let's take a look at another one I got here. Oh, yeah. There's just 5. There's not 6. There's just 5. This one was a fun one. I wanted to do something like this. Cosine x times cosine of sine x dx. Okay, what do you think our u is going to be? Sine of x, right? So the u is going to be sine x. Now, we have to keep straight in our minds derivatives and antiderivatives, right? You have to remember when you're going forward and when you're going backward. Like I am finding the derivative of sine. What is the derivative of sine? Just cosine, right? Antiderivative would be different, but derivative of sine is just cosine. Cosine x dx. Now, do you see cosine x dx within my original? Yes. Cosine x dx. So I can take that out and put du in. So this is going to become the integral of cosine of u du. And now I can evaluate that. I can find the antiderivative. Now, what is the antiderivative of cosine? Sine, just plain old sine, right? So sine u plus c. And then in the end, just go plug that x back in. So sine of x plus c. That one comes out so clean, I feel like. It's just so nice. So fancy. So simple. Okay, last one I got for you here. So we've got the integral of e to the x, 2 plus e to the x squared dx. It's like one of those problems that, like, if I showed you this at the beginning of the year, you'd be like, there's no way I can do that. But now you know. Now, because you guys are smart now you know that this problem is probably easier than a lot of the other ones. Why is it probably easier than a lot of the other ones? What's it got in it? E to the x, right? Right, never change. So u looks like it's 2 plus e to the x. So that means du is e to the x dx, right? Because the derivative of 2 goes away, the derivative of e to the x is just e to the x. So it's du is equal to e to the x dx, which is so great because e to the x dx is there. It's like puzzle pieces, right? Just got to find out where they fit. So this is going to turn into the integral of, looks like I've got 2 plus, sorry, u squared du. Oh man, that's nice. That is nice. U squared du. Okay, so that means this is going to be a u to the third over 3 plus c, and then I go back and plug in. Okay. I say 2 plus e to the x to the third over 3 plus c. Done and done. Again, those are all indefinite. Well, I gave you one definite in there. But again, the definite ones, you just change your a and your b values, and then you don't have to put in the plus c. You just evaluate at that point. Remember that the output, the final answer to a definite integral should be a number, should be an area, right? The final answer of a definite should be an area. The final answer to an indefinite should be an equation. Don't forget your plus c's. Don't forget your plus c's. Sound good? Cool. All right. Well, then I'll just let you work. If you watch along at home, so long, farewell.